Hello everybody tuning in. I hope you're all having a great day so far. And in today's video, we're going to carry on looking through sports and exercise science course. In particular today, we're going to be looking at the key topic of biomechanics. So, taking a look at biomechanics as a whole, what it is the study of mechanical laws relating to movement or structure of living organisms. So basically, throughout this topic, what you'll be looking at is different types of muscles. You'll also be going into a lot of detail of the skeletal system and of the different functions and roles, how movement can occur from that. But also you'll look at the physics side of things, so looking at force, angular kinematics and kinetics and stuff like that. So without further ado, we'll move into his first topic. So to begin with, the first piece of content that I learned at least was about muscles. Now there is a bit of overlap between physiology and biomechanics in relation to the musculoskeletal system. But during my time in biomechanics, what I learned was about the different types of muscles. So you got the skeletal, cardiac and smooth muscles. And in relation to the skeletal muscles, we learned about the properties of that. So the four different properties there are is contractility, which is the ability of a muscle to shorten and hence produce movement. Excitability, which is then responding to a stimulus by generation of an electrical signal. Extensibility, this is so that the muscle can stretch or extend, which is key when performing a contraction, same with shortening. And also elasticity, which basically ensures that once the muscle has stretched or shortened, it can resume their resting length after extending, for instance. Now, you'll also learn a lot of different other topics, so structure of the muscle, so what it's composed of and how it's made up. You'll also look at the connective tissue sheaths, different muscle fiber types and how they have an effect on performance, and you'll also look at different muscle contractions. So you've got isometric, for instance, which is basically the muscle does contract, but no significant movement occurs. So for instance, like a plank position. I think that's the best example I can give. And with isotonic as well, that's the opposite. So obviously the muscle contracts, but movement is produced throughout that contraction as well. And that's the general gist of what you will be learning in consideration to muscles. Now, next up, what we're looking at is the skeletal system. Now, this takes up, I would say, at least half of the content on biomechanics because I've condensed it down into one slide, but each part of a skeletal system that you can see on here takes up a full week, I would say, of content because you go very in depth on each part. And you'll look at the bony landmarks, you'll look at the different types of bones that are there, the different movements that are produced, and also the key muscles that coincide with the different bones and bony landmarks that are on there as well. So a lot of content to delve into. And basically, the different areas of a skeletal muscle system that you will be engaging in is the trunk and vertebral column, the shoulder joint and girdle, the elbow and radioulnar joints, the hip and pelvic girdle, and the knee and ankle. And looking at all those different areas, like I say, you'll go in depth, looking at the bony landmarks, different movements that can occur, and there's a lot of content just on the skeletal system alone. The next piece of content that we looked at after the skeletal system was the neuromuscular biomechanics of the body. And basically what this is looking in depth of the nervous system. So you're looking to detail on the neurons, the axons, the dendrites, that sort of stuff. You'll also look at the synapse, which is the gap between the axon and dendrite of different neurons. So you'll understand what occurs there. And a little bit like psychology, there is a tiny bit of overlap. You'll also be looking at the brain and the neuromuscular side of things like that. In particular, the motor cortex. And finally, another thing that you'll look at is all about reflexes and the stretch reflex. So I'm not sure if you've heard of PNF stretching before, which is the proprioceptive neuromuscular facilitation. And this is basically where you stretch your leg past the stretch reflex using a different combination of stretching methods. Now, we've finished with more of the biological side of biomechanics. Now we'll move on to the more physics side of it. And to begin with, we'll take a look at force. So, what force is, it's an interaction between two objects that can cause an object to accelerate either positively or negatively. So, if we take a look at force as a whole, you have gravity, that classes as a force to begin with, and I believe it is 9.81 meters per second squared, if I can remember off the top of my head, which is the maximum amount of acceleration that can occur due to gravity, as gravity is constant. Now, taking a deeper look into force, you'll go into Newton's laws of motion. So to begin with, you have the law of inertia, and this is 1 out of 3. And law of inertia is the velocity of a body does not change unless a resultant external force acts on it. So basically, a body will continue at the same velocity unless something external interferes, basically. The second law is the law of momentum. So this is when a resultant external force acts on a body, the rate of change of the body's momentum is proportional to the force and takes place in the direction of the force as well, so in the same direction. And finally, what you have is the third law, which is the law of reaction, which is in any interaction between two bodies, the force exerted by one is equal in magnitude but opposite in direction to the force exerted by the other. So every force that you create has an equal and opposite reaction. So, for instance, if you're playing tennis and you hit the ball really hard, you might think that you're creating a greater force on the tennis ball, but that tennis ball is also creating the same force but in an opposite direction as the tennis racket. Now, other things that you'll also look at is momentum, which is a product of a body's mass and its velocity. And there is a bit of maths in this side of it, as it is physics. So you look at different equations. So, for instance, what force actually is mass times acceleration. And the most fun that I think I've had is biomechanics, which is great, is the ground reaction force. Basically, what we did was using force plates. So, in particular, we looked at gait analysis, which is basically what we were doing. We were walking on these force plates, and using the technology that was at our disposal, we could see how much force was being produced with each step. And you could also see where my foot first placed down at the back to then the takeoff at the end from my toes. So it was really good. We could understand how much force I was applying to the ground with walking, and then comparing it to how much force say I was doing when I was running. So very interesting and cool technologies that we used in that scenario. So after looking at force, we looked at angular kinetics, and the first thing that we looked at in angular kinetics is about levers, which are a rigid body that rotates about an axis, which is the pivot or fulcrum. Now, there's two other areas that we can look at other than the pivot in levers, and that is the load, which is also known as the resistance, or the effort, which is the force. Now, different levers, like for instance, the second class lever is mechanically advantage, and that is because their effort force arm is greater than the resistance arm, and therefore it becomes a strength lever. So it can move a large load with small effort. However, if you look at the opposite side of that and look at the third class lever, which is mechanically disadvantaged, the resistance arm is further away from the pivot than the effort force arm. So therefore it becomes a speed lever, and loads can be moved quickly through a large distance due to that. Now, other than levers, in fact, I'll go on to the first class lever and why that doesn't have a special type. Both the effort and the resistance arm are the same length, so there's no mechanical advantage or disadvantage there. Now, we move on to Newton's laws of angular motion instead of Newton's laws of motion that we looked at in force. Angular motion, it suggests that a rotating body will continue in a state of uniform angular motion unless acted upon by an external torque. And what torque is, basically in brief terms, is just the angular equivalent of force that we looked at previously. You will also, in angular kinetics, delve into moment of inertia, which is the measure of reluctance of an object to change its angular motion. And we look at different things like gymnastics. So, for instance, if you're doing a front flip, you will curl it to make a smaller surface area, kind of, when you're rotating in the air, and that makes you rotate quicker than if you try to do a backflip, but you just stood up straight all the way through. You'd probably face plant the floor by doing that. So, to understand that by curling, it increases rotation and value and torque to ensure that you do go around to do that backflip or front flip that you're trying to perform. Additionally, you'll look at conservation of angular momentum, and there's different in linear momentum and angular momentum that you'll get into as well. And you'll also look at different stuff like angular velocity as well. And that all comes round into angular kinetics. And the final piece of content that we looked at is kinematics. And yes, this is different to kinetics that we've just looked at, though they do sound similar. Kinematics is basically the branch of biomechanics that describes motion. And you've also got angular kinematics as well, because there is angular and linear kinematics, which basically describes angular motion. So, before I go into too much detail on the kinematic side of things, I'll go through some of the technology that we use to capture the motion of, say, a sprinter. So you'd use 2D and 3D capture. You look at different camera settings and how that can affect the motion capture, such as frame rate and resolution. And then we also use this very cool software system called SimiMotion, which is basically used to digitize the motion in place. So you'd put a point on each joint, say the knee joint or the elbow joint, and you go through each frame by frame of, say, an athlete sprinting, and you'll be able to create sort of a stickman that goes through the motions that they performed, and then you can use that to then analyze them. So moving into the actual kinematics, and so you'll look at the distance and the displacement. Now, the distance is different from displacement. The distance is the length that they travelled, and the displacement is the shortest, basically, straight line from the starting position to the end position that you can work out. You'll also go into velocity, speed that you can use, and calculate in different areas there. And when looking at angular kinematics, it's slightly different, because you'll look at the angular distance, and the angular displacement is instead, which is slightly different. You'll also, in angular kinematics, look at angular acceleration and angular velocity, whilst in linear, you've just got your normal velocity and normal acceleration. And then finally, on an end note on angular kinematics, you will look at, say, the projectile motion and the projectile angle and things like that. So, for instance, say if you kick a football, that will have a different projection than if you hit a shuttlecock. A shuttlecock goes far really fast and then drops quite sudden because of the way the shuttlecock's built, but a football would continue that path a little bit longer. Now, in terms of the assessments, it's pretty similar to the other key topic areas for this course. You'll have an exam, this time multiple choice, and you'll also have to write up a report, like I've mentioned previously, on a certain topic in biomechanics. And that is it in consideration to biomechanics, everyone. Thank you all for listening to the video. I'll quickly go through each topic that we went through. So we looked at muscles, the skeletal system, which plays a big part, neuromuscular biomechanics. Then we ventured more into the physics side of biomechanics, looking at force, angular kinetics, and then finally both linear and angular kinematics. And then obviously we've got the assessments at the end. So thank you all for listening, and I hope you have a nice rest of your day.